Let's take a look at selectivity in a demonstration and see how this impacts indexing. Once again, we'll use the applications table, and just to make sure that we're starting fresh, I removed all the indexes from this table except for the primary key. The first thing that I want to do is to get a row count on this table, because that's the denominator in all of our calculations. So to do so, we'll run this query from the slides, and we see that we have 90,000 rows in the table. So this isn't nearly as large as some of the tables that many of you are dealing with in your applications, but it's large enough to perform some demonstrations against. So first we're going to look at selectivity of a single column, and we're going to do that on the last name column. So to find the number of distinct last names, we're going to run this query here. And we see that we have about 15,000, a little bit under that, of distinct last names in our table. This selectivity value comes out to a value of 0.15, so that's somewhere sort of in the middle. Let's take a look at distinct keys for each column in the table so that we can get a feel for the relative uniqueness in each column. And so to do this, we're first going to gather stats on the table. Okay, so now we've gathered stats. And now we're going to run this query that we had from the slides. So we see columns like phone number and email are at the top of the list, and these are very unique. We've got a pretty good drop-off down to last name and zip code. Those are similar in terms of uniqueness, but there is quite a bit of a drop-off. And then we've got a pretty significant drop-off down to first name and date of birth. These columns just really aren't all that selective. And so what this is telling us is that if we create an index solely on a field like date of birth, that probably wouldn't be very effective or only marginally effective, because at least in this database, that column doesn't tend to be very unique. Let's take a look at the selectivity of a couple of columns in a combination now. And to do that, we're going to take a look at last name and first name together. Again, to do this, we have this query from the slides, and we'll run that. And now we see we have many more unique combinations when we have both of these fields together, around 81,000. Before we were just a little bit under 15,000. So this gives us a selectivity value about 0.9, and that's much better. So now that we have some calculations and some numbers to keep in mind, let's go ahead and run a couple of examples and see how this impacts your indexes and the queries you run against your database. So the first thing that I'm going to do is I'm going to create an index, and I'm only going to have one column in that index, the last name column. There we go, the index is created. And now I'm going to run this query that we've been using against our database, and I'm going to run it with an auto trace here. So we can see that we are indeed using our index here. However, we can only use this index to get the entries that have the matching last name. And that turns out to be 347 rows. And then Oracle has to go read all of those rows out of the table, and only after that can it perform the comparison on first name. So even though we're using an index here, our query really isn't all that efficient. We have a cost of 341, and we're having to read 321 blocks from disk. This is driven by the fact that we really aren't that selective in our index. So we're getting back a lot of rows from this index that we have to perform some subsequent processing on. So let's go ahead and drop this index. And now we'll create a better index. Let's clean up our window hit a little bit first though. And now we're going to create an index on both last name and first name. Okay, so there we go. And now let's run our query again with an auto trace and see what happens. And we see now that we're much more efficient. The cost of the query has dropped all the way down to 2, and what this is driven by is the fact that our index is more selective. We're getting back many fewer entries from the index, and because of this, there are fewer rows that we have to go and look up in the table and read those blocks off of disk. So the learning to draw from this is we want to make sure not just that we're using an index, but we also want to make sure that we're being as selective as possible when we're using that index. This may mean making sure that other criteria that are in the where clause are also in the index, because this allows Oracle to read fewer entries from the index, and this is going to save us time and resources up on our database server.